Hi everybody, this is Mrs. Ewald signing in, and today we are going to be doing balancing, which is super fun, super fun. Um, by the way, I just have to say, balancing has to be one of the most relaxing things you will ever do in chemistry. In fact, I highly recommend on a Sunday morning with the snow outside, sipping on some hot cocoa, in your snuggie with your socks on and a blankie and cozying up by the fire with some balancing equations to do. It is the best thing ever. It helps my blood pressure. Anyway, let's get started. For balancing, the first thing you need to understand, we talked about this a while ago, and that's the law of conservation of matter. And you should remember, law of conservation of matter, that matter going into a reaction should equal the amount of matter coming out of a reaction, because matter is neither created nor destroyed, so we have to account for it. And so we have a series of many different reactions here, and each of these reactions are showing you the reactant, so what goes into the reaction, and then the product, what comes out of the reaction. And the way that we have them written right now does not make sense. It should not make sense to you. For example, let's look at the first one. You have phosphorus reacting with oxygen to produce or yield P2O3. Well, there should be a red flag going off in your head because your brain's saying, wait a minute, this doesn't make sense. How could you have one phosphorus going in and two phosphorus coming out? Holy moly, what's going on? Well, that is because this is an unbalanced reaction, and what we need to do is practice balancing them to show the law of conservation of matter. So I'm going to set this up first by doing a chemical inventory. I do a T-chart. This is very old school because I'm old. Mrs. Heaton might have a hipper way of doing it, but this is the way I was taught. So you have a T-chart, and the first thing I'm going to do is a chemical inventory. So I'm going to count up how many I have on each side. So I have one phosphorus. I just do the dash to signify what it is labeling. I have two oxygen. What I do is I look at the subscripts, and then you total them up. So I have one phosphorus, two oxygen. So these are my reactants going into the reaction. Over here on the right side are my products. And I have two phosphorus in that molecule and three oxygen. So there are many different kind of ways that you might feel comfortable doing this. You will eventually, your goal is to be able to just look at it and balance it. But first, by starting off with this chemical inventory, you notice right away phosphorus doesn't balance and neither does oxygen. But what is the best way of doing this? Well, I note here, what we do is we place coefficients in front. And the coefficient in front is the best way of balancing. And so if I have three oxygen here and I have two oxygen here, I need to get them to balance out to equal the same. So I'm going to place a 2 here to make this 6 oxygen. But that also makes my phosphorus now 2 times 2, so that's 4. Over here, if I place a 3, that makes my oxygen equal 6. That's what I was trying to do. But now my phosphorus is not balanced. I have 4 here and I only have 1 here. So I place a 4 in front of the P and now it's balanced. The next thing to do is make sure that all of my coefficients are the lowest whole number ratios. Otherwise you need to reduce them. So looking, I have 4 to 3 and 2. That is the lowest ratio I can have. So I am done. Next one. Do your T-chart. Do your chemical inventory. You have 2 hydrogen and 2 oxygen. Over here you have 2 hydrogen and 2 plus 1. Do you see that? You have the 2 plus 1 oxygen on the right. So going through, what should we balance first? Looking at this, because hydrogen here is blatantly obvious, it's the first one. Hydrogen is so far balanced, right? It's the oxygen which doesn't balance. So how can we fix that? Well, I'm going to place a 2 here. Why? Because I'm trying to get to an even number because it's a lot easier. So 2 plus 2 gives me 4 oxygen. And then over here I could just place a 2 in front. That gives me 4 oxygen. But now that's messed up my hydrogen. But that's okay because now I have 2 times 2, 4 hydrogen on the right, 2 times 2, 4 hydrogen on the left. Now, you got to be having a lot of fun already, right? I mean, come on. This is loads of fun. Let's do the next one. Now we're getting into polyatomics. And let me show you what we do with polyatomics as best as you can. Do your T-chart again. Notice how I'm going to keep the polyatomics together. So I have 1 zinc, I have 1 lead, and I have 3 nitrate. So 3. And that would be, yeah, nitrate. Over here on the right, I have 1 zinc, 2, and 1 lead. And now what we're going to do is easily fix our polyatomic. So I have 2 over here, and I have 3 over here. Ooh, what can I do? Just like I did above in number 1, I could place a 3 here to make this 6. That makes my zinc 3. And then I could place a 2 here to make this 6. Makes my lead 2. And now I just need to balance my zinc. Make this 3. And my lead. Make that 2. And now everything checks. And it's the lowest whole number ratio. Let's go ahead and do one more. So go ahead and count it up. You have 2 Sp, 3 S, 1 hydrogen, and 1 chlorine. Over on the right, you have 1 Sp, 3 chlorine, 2 hydrogen, and 1 S. All right, and now looking at these, what should we do first? Well, I'm looking, and first off, the Sb, right? I'm going to make this 2 here, and that now throws off my chlorine, so that makes this 6. And then, if I go back over, I see sulfur has 3 here, and I only have 1 here, so I make this 3, and that makes my hydrogen 6. Going back over to the left, I'm going to have 6 hydrogen and 6 chlorine. That makes that balance, and I'm done, just like that. So again, I'm going through my inventory. I'm checking to make sure I have equal amounts on each side. If I don't, then I just keep going through, going back and forth until it does balance. And then always make sure you have the simplest ratio. All right. The last one. You should recognize this from types of reactions. We have a hydrocarbon, CH4, methane, and oxygen. And you should know, because we talked about this already, that when you have a hydrocarbon and oxygen reacting, you're always going to form CO2 and water. So that will always be the product for that. Always, always. The only difference is the coefficients because of balancing. And so I call this a CHO problem. CHO. Reason why is you want to balance in that order. CHO. Okay? If you always balance in that order, you will always not want to pull your hair out. So going through, I have 1 carbon, 4 hydrogen, 2 oxygen. And here I have 1 carbon, 2 plus 1, 3 oxygen, and 2 hydrogen. So if I start with my carbons are good. Moving on, hydrogen. 4 over here, and I only have 2 here. Place a 2 in front. That makes that 4. Good. Done. Done. Lastly, my oxygen. I have 2 here. I have 3 here. Oh no, what do I do? What do I do? I could place a 2. I have, 2 plus 2, so I have 4 by adding that 1 here. So I'm just simply put a 2 here to make that 4. And then I'm done. So it's a 1 to 2 to 1 to 2 ratio there. So, hold on 1 second. This got funky on me. If I close it up and open it, gets better. All right, so advanced tips then. Always treat your polyatomics as single units. Do not break them up. So example here, if you go through and you were to do your inventory and add them up, but simply we have 3 sulfate here, 2 hydroxide. We only have 1 sulfate here and 3 hydroxide here. So, what could you do? I see this hydroxide and this hydroxide. I'm going to put a 2 here and a 3 here to make them 6 on both. And I could simply put a 3 here to make my sulfate balance, and that also then balances the rest of my equation. So I just did that without doing an inventory, and that's how fast you should be able to do it. Check to make sure, but everything else should balance. The last thing I want to talk about is fraction. Oh, excuse me. It's fraction problems. And again, this is whenever we deal with a CHO, a CHO, when we have a hydrocarbon reacting with oxygen to produce CO2 and water. Always write out the equation for the reaction in case it's not finished for you. You should always know it ends up with CO2 and water. And then, if you could only use fractions, that's what we'll use, and then we're going to multiply and get it to whole. So let's go ahead and do this one. I'm just going to rewrite it out here. So C10H22 and oxygen yielding CO2 and water. All right. So I'm first going to go ahead, do my inventory. I have 10 carbon, 22 hydrogen, and 2 oxygen. I have 1 carbon, 3 oxygen, 2 hydrogen. Remember, CHO. CHO, start with your carbon. I have 10 carbon on the left. I'm going to make 10 on the right. That will also change my oxygen. So now I have 10 times 2. That would be 20. And then I would, well, hold on for a second. We'll go to that in just a moment. Let's look at the hydrogen, right? And then we'll go back and count up our oxygen. So strictly just go carbon, hydrogen, oxygen. So let's do hydrogen. I have 22 on the left, and so I need to get 22 on the right. Okay, now let's count up our oxygen. So we have 11 plus 20, so that makes this 31. And now going over to the left, notice our carbon is good, our hydrogen is good, now it's just our oxygen. And so I need to get 31 on the left for that oxygen. The only way I can get 31 is if I use a fraction. 15 and a half will give me 31. Now, you will never, ever, ever, ever use a fraction as a coefficient ever in your final answer. So what you need to do is multiply all the coefficients till they're all whole. So you multiply by the simplest whole number to get to the closest whole number. And so I'm going to multiply everything by 2. So I'll put a 2 here. That makes this 31. That makes this 20. And that makes this 22. You would then go through, rewrite it out in case you had to show your final answer so it's nice and clean. And voila, you're done. So that is an example of a CHO, what I call them CHO, showing you having to use a fraction, multiply till whole. What you're going to do is practice, 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 because that is the only way you're going to become very, very, very good at it. Okay? This is Mrs. Ewald signing out. Enjoy, enjoy, have fun with it. Happy balancing.